Okay, so now that we have 1 over here, okay, so that came from x sub n minus 1 all over x sub n minus 1, so we're going to get a 1. And then plus x sub n minus 2 all over x sub n minus 1 is equal to this ratio that we have here. So that's all going to be equal to phi. Okay, and then so we have here, if you notice, x sub n minus 2 all over x sub n minus 1. If you try to flip them, okay, so you have your x sub n minus 2 and this x sub n minus 1. If you flip them, okay, we're going to get the reciprocals. So if x sub n minus 1 all over x sub n minus 2 is equal to phi, then if you flip them, okay, if you try to put the numerator from the denominator and the denominator to the numerator, then you're going to get the reciprocal of phi, which is 1 over phi, which is just simply using the property of inverse multiplication. And from there, okay, we can get this equation. So 1, okay, 1 plus 1 over phi, the reciprocal of this one is equal to phi. Okay, essentially this one. So that's the substitution for statements number 6 and number 7. And from here, we can try to remove phi here at the denominator, so we can multiply the entire equation by phi, or the golden ratio, or the Greek letter that we still don't know yet the value of the golden ratio. So there you go. We multiply that to phi. This cancels out the bottom, and we get here phi plus 1 is equal to phi squared. Okay, and then we can rearrange this into a quadratic equation. So therefore we get phi squared minus phi minus 1 is equal to 0. And therefore, by using the quadratic equation, we can say that phi plus 1 over 1 plus or minus 1 plus 4, okay, 1 plus 4, because we got this by 4 times 1 times negative 1. Okay, so therefore we got here plus 4 all over 2 is equal to 1 plus square root of 5 all over 2 and 1 minus square root of 5 all over 2 using the quadratic formula. Oh yeah, the quadratic formula. And from here we get the values of phi, which is 1 plus square root of 5 all over 2 and 1 minus square root of 5 all over 2. And that's how we got the golden ratio based from the Fibonacci numbers.